Okay everyone, we're starting on page 3, second section in your book. Hard facing is applying a layer of hard, wear-resistant metal to the surface of a softer metal. These hard facing applications are used in mining, logging, pulp and paper, and the railway industry. Hard facing electrodes can be self-shielded, gas shielded, and for submerged arc welding processes. There are many hard facing products, and they are all for restoring parts to their original size. Always check the label for ventilation requirements. The ingredients used in this stuff is not good for your health. These types of wear, abrasion, impact, erosion, corrosion, oxidation, and thermal shock are all terms that you need to study for your test. Page 5, hard facing wires are selected by the type of wear the metal will be exposed to. High-speed steel is good for metal-to-metal wear at high temperatures. Austenitic manganese is horrible for your health, but has the benefit of work hardening, which means it hardens the more it is worked. Tungsten is extremely hard, and nickel chromium retains hardness at hot temperatures, usually on high-strength, low-alloy steels. Page 8 shows recommended preheat temperatures. For most hard facing, preheat is not required. The base metal should be at room temperature though. If hard facing is going to exceed 2 or more layers, you would need to butter the worn material with similar composition first, then apply the hard facing. Manganese steel is highly used due to its self-hardening properties and must be watched for overheating or it could crack. Interpass temperature is ideally kept below 500 degrees Fahrenheit for manganese steels. Common hard facing patterns are the waffle pattern, which traps dirt and sand. Stringer beads ran in direction of the material flow, and a dot pattern, which is fast to apply and most economical. Dilution can be an issue with flux cord hard facing. This happens when the base metal gets too hot and mixes too much with the weld metal and leads to micro cracks near the welding line. 100% CO2 increases penetration, which can increase problems with dilution. Best way to control dilution is to try to use low current settings. Page 11, spalling is the loss of weld metal from the base metal due to cracking. Controlling the cooling rate and limiting deposit thickness will help reduce spalling. Underbead cracking usually happens in the heat affected zone in low and high alloy steels. Stress failures are usually found at the toes of welds. Since hard facing materials are much harder than that of the base metal, cross-cracking is common. Cross-cracking helps to relieve internal stresses, and if you get excessive cross-cracking, apply small amounts of preheat. Distortion is a problem when applying heat to materials. Try not to overweld or overheat the part, and staggering where you weld can help spread out the heat. Few notes here. The test for this book is 50 questions. You can check your Moodle for some additional resources for studying.